Hello. I am communicating to you again from the digital domain to teach this lesson. Thank you to the substitute for getting this up and running. And substitute teacher, hopefully, if you like, you can pause the video at any time to let students get out ahead and figure things out for themselves. And I'll run along through our mental math and our examples. Yeah, especially, there will be a time to make some graphs, and mine are already made. So you'll need to pause the video to let students make their graphs. All right, let's get started. Mentally math, let's get mental. So speaking of pausing the video, now would be a good time. Let students get out ahead of me. I'll just wait a moment. Okay, and we're back. All right, so starting out, positive and negative numbers, and a little bit of trickery with the exponents. So this would be negative 2 times negative 2 is just 4. And then remember, now we've been working a lot with these with an exponent, or with the number 10 as in our scientific notations. But so do keep in mind that the negative exponent does just kind of turn this into a fraction. Right, so this is the equivalent of 1/4. So 4 and 1/4. In scientific notation, we are dividing this time. So 5 divided by 2 is 2 and 5/10. And then remember, with exponents and like numbers, and we're dividing, the rule is to subtract them. Okay. Then, algebra. So let's see, we would say 2 and 4/10 minus 1 and 2/10. That'll get us 1 and 2/10. Then divide that by 3 will get us 4/10. And then, the metric system. So elegant and simple. But boy, this one has a lot of zeros, because keep in mind, when we are talking about 1 square meter, we're talking 100 by 100 square centimeters, right? So that ends up being a lot of zeros. It ends up being 1, 2, 3, 4 zeros for your 100 times 100. Square centimeters. Okay, so this is just 400 plus 1/4 of 400 is $500. And this is also 400 plus 1/4 of 400 is $500. Okay, primes and composites. Which does not belong to the list? 2, 23, 41, and 48. Well, they give away the hint here, which is to say that we're talking about primes and composites, and most of these are prime numbers, except for the 48. 48 does not belong there. And hopefully people noticed, we are talking about estimation. So I can think 9% of $40, and so 9%, I can kind of think like 9/10 divided by 10. So 40, basically 40 minus 10% divided by 10 is what I'm thinking. And that might sound a little weird, but so 40 minus 1/10 is 36, then divided by 10 is, oops, I don't want GP red, is 3 6/10. But since we're talking about money, is $3.60. Okay, so today we're talking about slope-intercept form of linear equations. And yes, we are into the last 5 lessons of the Saxon math book. And, well, it's going to kind of show in this lesson. Okay, so example number 1 is transform this equation so that it is in slope-intercept form. So what they're talking about slope-intercept form is essentially where is it on your coordinate grid that intercepts the y-axis, that runs through the y-axis. So essentially y has to equal 0. I'm sorry, x. X has to equal 0, pardon me, in order for it to be on the y-axis. So in order to do that, we just need to solve for y, so that we've got y on one side. Everything else will be on the other side. And then we can figure out what do we need for x to be on here in order to basically have x equals 0 in our equation. So, or what will y be? Okay. So first thing that we need to do here is solve for y. And so we are going to subtract 3x from each side. Right. So getting us to our stage 2 here of y will equal 6 minus 3x. And then we can kind of sort of make this look like it makes a little bit more sense by saying, okay, well, how about y equals 3x minus 6? Okay, so that now we have an equation for y will equal, and then this is our equation for getting that. Okay, so now that we have this equation, this is actually stage 1 in getting to our second equation, our second example. Okay, so take what we have just done and graph this using the slope and the intercept. So let's see what this is actually going to look like on a graph. And we're going to want to start out with using x as a value of 0 to figure out where exactly the y-intercept is going to be. So I'm just going to give you a minute to make your graph. So you should be drawing this. And then we will start out by saying, okay, where on this line is the y going to be? Which, I mean, mental math, you can probably just take a look at it and figure that out, because x has to be a value 0. Still, I'm sure the tension is building up. If the substitute would like to stop for a moment and let people catch up and make their graphs, that'd be great. I'll stop for a minute. And we're back. Okay, well, looking at this, finding the y-intercept, we can just think, okay, well, x has to equal 0. So you get something that looks like this, which basically negative 3 times 0 is 0. So this is 0 plus 6. So the y-intercept is 6. So that means, well, we go at the very top of the graph here. And we have now plotted our y-intercept for this equation. So next, we should figure out what's the slope. So what can we do? Think about it. So what we want to figure out is what is the rise versus run here. So the first thing probably to figure out is, well, what if we assign a value of 1 to x to see how far down it's going to go for every 1 that x moves forward. Right? So I'm going to rewrite the equation as y equals negative 3 times 1 plus 6. So doing that out, we would get y equals, well, negative 3 plus 6. Combining those values, we get us y equals 3. So here, I'll put our second thing. So for this then, y equals 3 and x equals 1. I'll plot that guy. Okay, and well, the book does 4. Maybe do one more. I don't know. I think at this point we could predict the last one, right? Okay, so what if x equals 2? But really, would we need to do anything further at this point? I'll do one more just for illustration purposes, but we have already figured this out. Is for every 1 we move forward, we're going to go down 3. Maybe get a better color for that. It's not. How about orange? But you know, I'm gonna do one more just to prove it. Okay, so this time, in here, why don't we mark that off too? Okay. So in this case, y equals negative 3 times our value, x value is going to be 2, plus 6. So that gets to y equals negative 6 plus 6, which will get us to y equals 0 and x equals 2. So this time, here we are. Right. So from there, we could probably predict, right? Okay, so we now essentially knowing that our slope is equals negative 3. Slope. Our slope is negative 3. We can just predict these of, okay, well, if I go forward 1 more, I need to go down 3. Oh, didn't mean for you to be that color. And so forth. and so on. Okay. Now this is actually going somewhere sciencey and practical. We will get there. Okay. I'm going to maybe try to hurry through this one, because this actually seems a bit simpler than the last one, to be honest with you. Okay, using only the slope and y-intercept, graph y equals x minus 2. So, first of all, how can we figure out our y-intercept? Our y-intercept is if x equals 0, so that we can be on this line, on that line, on that line. Okay. And so we'll say y equals 0 minus 2. Okay. So then that would mean the y-intercept is minus 2 if x is 0. Okay, and this is kind of an interesting equation. So what if x is 1? It kind of just goes to show that, so if x is 1, then 1 minus 2, it's going to be y equals negative 1. If that's at 1. So that'll end up there. And then from there, we already know that we have a slope of 1. Oh, please do not come in right now. I am recording my lesson. Sorry, people at home. We're getting ready to go to the dentist. Okay, which means I need to hurry up. All right. So, this gets interesting. Robert noticed a bird's nest in line with the slope of his roof. He knew that the slope of the roof was 4 in 12. Okay, well, essentially, I mean, if we're going unit by unit, that'd be a slope of 3, but we don't need to think like that necessarily. We can use the 4 in 12 probably more efficiently than a slope of 3. He also knew that the edge of the roof was 8 feet high. He measured 48 feet from the edge of the roof to a spot directly under the nest. Then he calculated the height of the nest. How high was the nest? So I'm sure this doesn't seem very simple. But with a series of simple steps, we can totally solve this. Let's get this. And a table. And I'll make this as large as I can. Okay. So if you would like to pause the video and discuss this, that would be perfectly fine with me. I'll wait a minute. And we're back. Okay, so one thing we can see is that we can go into units of 12 feet because the overall length is a length of 48, and the 12 feet is our unit of kind of rise. So we can say we've got 12 feet is our first unit. And then by about halfway, 24 feet and 3/4 will be 36 feet. And then finally we're at 48 feet here. Okay, and we could even kind of mark where we're going to be, right? And so we can kind of see that now we are considering this to be our unit. Well, basically we're starting at a height of 8 feet. So our equation would probably have a bit of a plus 1. Essentially, and I'm going to put the equation over here. I think actually looking at it and just doing it step by step is perhaps a bit more intuitive than doing the equation out. But the equation we've got here is y and 4/12. So that being our kind of rise and run, okay, multiplied by 48, and then the height that we're starting at is 8. So I'm just going to put that in the corner there because I think it kind of demystifies this a little bit more just to see what we're doing at each step. So when we run forward 12 feet, we are going to be rising 4 feet above our 8, right? So we're going to do plus 4 to get to here. So at that point will be 12 by 12 feet. Wow, that's a good color for that. Okay. And then if we go to our 24 feet, our point up here, right, then we are once again going up 4 feet. So we'll be at a height of 16 feet. And then going forward to our 36 feet, we go up, you guessed it, another 4 feet. So up here we're at 20 feet. And so once we get to green, our 48 feet up here, that's where our bird nest is up here. And we just go forward our last, we go forward our last 12 feet to 48, and we go up our last 1, 2, giving us an answer of the height is 24 feet. Okay, or you can solve for this. Either way. Okay. So please do all of the odds. I will see you tomorrow. Have a great day. The history geography is on the history geography playlist. Please go there for history geography. Okay, bye.